Okay, so if when someone is talking about C, it sounds to you like they're talking about an entirely different language. It's because they are. And I know that learning a new language or programming language is really difficult, especially when you haven't done much coding before. So there are some things that just won't make sense for a while, and there are other things that should be beginning to make sense by now. Every program we write in C is going to have some lines at the top that look like this. Hashtag include stdio.h, like that. That is a library of code that we can use, but we can only use it when you write this include statement at the top. And in all of our programs so far, the only thing we've really ever used from this library is the printf function, which lets us output stuff to the terminal down here. Remember that the terminal, this is really just the computer. You can type commands on it and make the computer do things. Your code is up here in this file. I named this one littletimmy.c. You've often seen me type hashtag include cs50.h. That's a custom library that the creators of Computer Science 50 wrote that lets us use some functions to do things a little easier. Like this, if you see two slashes like this, that's a comment. And when the code compiles, the comment is completely ignored. It's like it's not there. So I can write a comment on this line. Let's just use get int and get float, those kind of things where it pops up a message down here and it asks the user to type something in, and then you type something in and hit enter, and then the code keeps going. That's where these functions come from. Stdio.h, and you have to spell it just like that. Lets us use printf, and there's a bunch of other stuff in stdio that we haven't used yet. Today, for the cache lab, you saw me type math.h. There's some, let's us use round and floor and ceiling and power and square root, and there are other things in math that we might use eventually. So usually those first 2 or 3 lines will be these include statements. You may not always need math. And then the next thing you'll see will be int main parentheses void inside parentheses, and then on the next line some curly brackets. This is one of those things that just doesn't make sense yet, and I haven't even tried to explain it yet. It's basically this set of stuff is in Scratch when green flag clicked. That's the same thing. This is just where the code goes to start running. And all the programs we've written and all the programs we're going to write, most of the stuff you type is going to be between these 2 brackets that belong to main. And that bracket has to be the very next thing after main. And then all of your code goes here in between the 2 brackets, and then that bracket has to be the very last thing in the program. A common mistake is to accidentally start trying to, int my variable equals 10, like define a variable here, but above that bracket. And if I try to compile this, it's going to give me an error. And by the way that you compile code is you type the code you want up here in your file, then you go down to the terminal. This is your computer, remember? You type a command called make, a space, and then the name of the file, but you don't have to put the .c when you're using make. And if I do that and hit enter, this set of stuff right here, that stuff will always pop up after you run make little Timmy. That's actually what make is doing for you. You could type everything that I just highlighted and it would do the same thing, but who wants to type all that stuff? Make is a really smart program that does all that for you. So that's how we compile code. So you can ignore the first two lines. These two lines always pop up after you run make. That's really the output of make, and then this stuff runs, and then you get the output of the compiler down here. When there are errors, you will see them pop up right after these two lines. And so the first error is telling me there's an error in littletimmy.c, that's this file, and it's telling me it's on line 15, or line 5, character 15. So line 5, character 15. So if I count over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, that's where the problem is. It's not always going to be obvious if you go look at that spot exactly what's wrong. And like even here, the error message that they tell me is not actually the real problem. It says expected semicolon after top level declarator. And it points right there like, oh, you should put a semicolon right there. Okay, if I do that, and then I click make again, and by the way, if I click the up arrow on my keyboard, oh, never mind. We'll do that in a second. Make little Timmy. There's still going to be an error message. It's still messed up. Now it's pointing to line 7, character 1, and it highlights that there's a bracket there. And it says expected identifier or open parentheses instead of this. All of the error message, the last error message and this error message have to do with this bracket being in the wrong spot. Like there doesn't actually need to be a semicolon there. And so if you just look at the error and type exactly what the error is telling you, it's not necessarily the right way to fix the error message. And that's not because the compiler is dumb. That's because the compiler can't it can't anticipate every possible mistake you might make and have an error message ready to fix all of your possible mistakes. So usually when you're debugging, that's what this is called. I got something wrong with my code. I'm debugging. You can use that location, little Timmy, line 7, character 1, as a general guide for where to look. And then you got to think about what might be wrong. The bracket being under that variable declaration is the real problem. So if you put the bracket where it goes, right after int main void, right after that line, and then if this variable declaration is under that bracket and above that other bracket, now if I try to compile it, I don't get any error messages. If I try to run it by typing /little Timmy, it looks like nothing happens. My code actually ran, it's just that I'm not really doing anything yet. I never told it to print anything. I didn't do anything that is visible on the terminal down here. So it ran our code and it created a variable named myVariable and it stored 10 in it, but then nothing happened. So let's let something happen to it. If you want to use a variable, the first thing you have to do is declare it. You can do that like this, the variable type and the variable name, and then nothing but a semicolon. But before you use it, if you do it like this, before you use it, you have to assign something to it. So now I have assigned a 0 to my variable. The line above that, I declared it. I told C, hey, I'm going to only try to put integers in this variable. And then on the next line, I actually assigned something to it. You can do it across two lines like this, and sometimes that makes sense. Or you can do it all in one line. I'm going to call this one myVariable2 and give it a 10. This line and these two lines are kind of identical. They do the same thing. They declare a variable. They assign a thing to that variable. If I want to use the variable later, myVariable equals 10 or 100. After you declare a variable, you don't ever declare it again. You're going to get an error if you try to declare it again. So like this will compile, but if I type int in front of it again, just like on that line, and I have two lines where it says int my variable, this will not compile because you already declared it. You don't need to do it again. It's called declaring when you put the type in front of it like this. You can reassign a variable as many times as you want. My variable equals 20, my variable equals negative 30, and it just keeps overwriting what's stored in that. So right now, if I want to print what's stored in these variables, I need to use a print statement. And I can do that with, in C, you can do it with a function called printf. And then you put what you want to have print in parentheses, except the print statement in C is honestly way more complicated than it needs to be. The print statement in other languages is usually a lot simpler. So in C, you put double quotes, and then you type a message. My variable, or you don't have to type a message, but if you want to display a message, you can. My variable is, and then if you want to actually print the contents of this variable, my variable, you've got to use what's called a placeholder. That's %, and then the next thing you type depends on what kind of variable it is. If it's an integer, you type an I. You see how it changes color? It recognizes that %i is not the same thing as this message over here. It recognizes that %i is a placeholder. And then you have to tell the print statement what integer you want it to put in place of that placeholder. So I could type a 7 right here, and then put a semicolon at the end, and then hit make little Timmy. You have to recompile every time you change the code. If you don't recompile, it doesn't see what you changed. Okay, I just realized that you couldn't see the very bottom of the screen down here, so if you're wondering where the stuff in the terminal went, it's because I had to pause the video and change some stuff. So if I compile this again, and then I run it with /little Timmy, it prints out my variable is a space and then a 7, because that's exactly what I typed. My variable is, and then I put a space, and then I put this placeholder. So the way that printf works is it takes whatever is right after the comma and it replaces this placeholder inside of the double quotes with whatever is right after the comma. Now that's not useful if I'm just putting a 7 here, because I could have just put a 7 here and left the comma off, and this will do the same thing. /little Timmy. See, the output here and the output here looks exactly the same. So you would never use %i, the placeholder, and put a comma and just put a 7, because that's a waste of time. But you would use this stuff if you have a variable like my variable, this one. If I know that this holds something and it doesn't always hold the same thing, and I want to print what's in it, you have to use this placeholder right here inside of these double quotes. You don't need this message. If I just want to print the variable, I could just delete the whole message part. You got to leave the double quotes. That needs to be there, and that needs to be there. Put the placeholder, put a comma right here after the double quotes, and then put the name of the variable that you want to replace the placeholder. So if I print this, and then /little Timmy, it prints -30 now, because -30 is the last thing that was assigned to my variable. It started out as 0, then I put 100 in it, then I put 20 in it, then I put -30 in it. Every time you reassign a variable with an equals operator like this, it replaces whatever was in the variable. Remember that variables are just like boxes, and they can hold one thing at a time. Whatever you put in there, it holds that information until you put something else in there, and then it loses what used to be in there, and it holds the new thing. So there are other kinds of variables, like this is just an int, and most of the labs we've done so far have just used ints, but An int holds an integer. If you try to put something other than an integer in an int variable, it's not going to compile. Another type of variable that can hold an integer but that can hold bigger integers is called a long. And the difference between an int and a long is that longs use more storage. When you tell the compiler, hey, I'm going to use a long variable, it sets aside a bigger chunk in memory waiting to hold whatever you put there. So it can hold bigger numbers than integers can. There's a size limit for how big of a number you can put in an integer. And in the data types lab that we did, it says the computer only allocates 4 bytes, which a byte is 8 bits, so that's 32 total bits worth of space, or a number that's as big as 2 to the 32, which is just over 4 billion, which when you're dealing with computers, sometimes in some contexts, 4 billion might actually not be a big enough number if you're calculating really big things. And that's how many things it can hold. That's actually not the maximum. The maximum is 2 to the 31, which is about 2 million, just over 2 million. And it goes down to negative 2 million as well. So if you try to store, if this number is the biggest integer I can store, and I go back to my lab where I'm doing it, and I paste that. Let me get rid of those commas. We don't want to put those commas in. So here, long, let me actually make this an int just to show you. Int, my variable is this. And let me print. I'll print that one to show you what happens. We got to make little Timmy and then / little Timmy. So it prints it. 2, 1, 4. It prints it just fine. There's no errors. It compiles just fine. But if I add 1 to it, so if I just try to make it one number bigger, and by the way, the plus, you can add things with that plus. Now if I try to compile the code again, it says error, overflow in expression. That number is now too big for an integer to hold, for an int type to hold. But if I change this to long, and then make this a much bigger number, so what, 8, 1, 2, 3, 1, 2, 3, 1, 2, 3, 8 billion. That's way bigger than the number I just had there. We can compile this, and it works just fine. And if I do / little Timmy, we see that it prints out the number. Let me make sure that's big enough. 1, 2, 3, 1, 2, 3, 1, 2, 3. Yeah, that's way bigger than the number I had a while ago. So a long holds much bigger numbers than an int, but they still have to be integers like this. If you want to do something with a decimal, you've got to use what's called a float or a double. So a float can hold decimals up to, how big can it, let's see, it uses 4 bytes. So really the size of the number is a little different for decimals, because the way that the computer stores a decimal is that it really converts the number to scientific notation. And so if you have a bunch of digits, it might not be that big of a number. It might be 2.34877. Like, if you just keep going with the decimals, eventually it's going to run out of memory to store all those decimals. So if you tried to store pi for 100 digits, that would be too big to store in a float. Even though pi is not a really big number, it runs out of memory because of the different digits that it has to store. So if you needed to store more digits, you could use a double. A double uses 8 bytes of memory instead of 4 bytes, like a float. But other than the size of the variable, floats and doubles are very similar. You can store decimal numbers and do math with decimals. If you have a calculation that you expect might end up with a decimal or a fraction, then you have to use a float or a double. So for example, if I leave this 8 million here, there's no decimal. I didn't type a decimal in, but if I store that in a double and then print it down here, and I have to change this to %f to get it to print, that's if you look on my cheat sheet that I have on Google Classroom, there's different placeholders that you can use to print different kinds of variables if you need to print them. Most of our labs here on out may not actually ask you to print variables, but it's useful to print things when you're trying to debug something. So if I compile this, oh, I don't need to type the C, and then run it. You see how it puts the decimal for me, and then it just throws a bunch of zeros at the end? So when you store something in a double or a float, it makes it have a decimal, even if it doesn't need one. All right, let's look at some if statements so that you can make the program make decisions for you. I don't want to print that right now. So an if statement starts with the word if, it has parentheses, and inside the parentheses you have to type what's called a Boolean expression. Boolean expressions are only have true or false as their answer. So I could actually type the word true in there or the word false. Those are two key words that exist that you can use in very limited. It's kind of silly to type that in an if statement, but to show you, let me take actually this print statement and put it in the if statement. So, and instead of printing that variable, let me just say inside the if statement. So this print statement will not run unless the inside of these parentheses turns into true. Usually when you use an if statement, there's some expression here that has to calculate, like is x less than 10? And if that's true, then the code in between these two brackets will run. If this is false, this code gets skipped and it just goes to the next line after this. So let me put one out here that says after the if statement. And because I'm printing multiple things, it's all going to get jumbled up on one line unless I put that new line character inside the quotes. Let me put it down here too. That part doesn't actually get printed. That's just telling the terminal down here, go to the next line before you print the next thing. You have to have semicolons at the end of print statements. You do not put a semicolon right there at the end of the top of an if statement. And you never put a semicolon right after a bracket like that or that. They would never belong there. You put them at the end of expressions with equal signs like this. You don't put it at the end of int main, and you don't put it at the end of these. It doesn't belong there. You just kind of have to get used to where they go and where they don't go. Okay, back to the if statement. Let me change this to true and then run this code. Make little Timmy. All right, so it prints inside the if statement and then it prints after the if statement. Because that's true, it executes this code. If this were false, oh, by the way, this shortcut, you can type the up arrow or the down arrow to scroll through the commands that you have recently typed in. So make and then up /. Now, after I run it, I only get the one that's after the if statement. It goes through all this code. It starts here, goes through all these variable declarations, which actually I'm not doing anything with. It gets to the if statement. It sees that that's false, so it skips this and it goes to the next line after, and then it prints this. This is not how you really use if statements. You don't normally type true and false in there. Normally you type a variable and an expression. So here I've got a float, my variable 2 is 10.5. So I could do if my variable 2 is less than 20.0, then print this. Otherwise skip this and move on. So there's a few different commands you can use. There's less than, there's greater than, there's less than or equal to, there's greater than or equal to, there's equal to. You can actually check if it's equal to that. A super common mistake though is that you're going to forget that it needs 2 and you're just going to put 1 and then this won't compile. if you're trying to check if this thing equals that thing, you have to use two equal signs. What else is there? There's a does not equal, which could be useful sometimes. You put an exclamation point and then an equal sign. So if my variable does not equal 20, then do this stuff. So I'll show you that this one, if I compile it and then I run it, my variable actually holds 10.5, which is not 20. So this statement is true. When the code runs, it evaluates this expression and it basically replaces it with true. And then this runs. But to make it false, I could say if my variable is greater than 20, and then I can show you that this one will turn into false. Make run. So it only prints the one after. It doesn't print the one inside because that statement is false. That's how ifs work. And you can, the other thing you can do with ifs is there are these operators called or and. This is the or operator. So if I write this, I know that 10.5 is actually in my variable 2. I meant to put a 2 there. If I write this, it checks this first one and it realizes that that's false. Then it sees that I put the or operator. The or operator means that it's going to check both. And if just one of them is true, then the whole thing inside parentheses gets replaced with the word true. It doesn't actually change the text, but that's how it works. It acts like it just replaces the whole thing with true. If both of them are true, it still is true. But the only time that this thing is false is if both expressions are false statements. That's how or works. The other thing you can do is and. And requires that this thing be true and that one on the left, keep highlighting too much. That one and that one both have to be true before the entire statement is true. So if I run this with the and connecting them, it's going to be false because my variable 2 is not greater than 10.5. Even though it is 10.5 and this one's true, the and means both things have to be true. So with and or, by the way, this key is above the enter key. If you hold shift and hit the /, it puts a vertical bar. You have to put 2 of them to stand for or. Another thing you can do with if statements is use else. So an else will always happen if the first thing is false. So if this stuff is false, it skips what's in the if statement and then it executes what's in the else. So if I move this print statement up here and I say, let me change it to say inside the else. I know if I put 2 ands here, I know that this will all be false. Actually, I mean, this one's true, but that one's false. So the whole thing will be false because I connected them with and. So since that's false, it's going to skip this print, see that there's an else, and then it will just execute the else automatically. So let me do make little Timmy and then /little Timmy, and it doesn't print inside the if, it prints inside the else. If I connect this with or, this whole statement will be true because that one's true. Then it will print this, but it won't print this. That's how else works. Compile, run. See, it just prints inside the if. You should connect things with else's when you know that there's only one of the things that you want to be true, or one of the things that you want to happen. And if you have a bunch of stuff, you can keep doing if else's or else ifs. You could test my variable equals 5.0. You could keep going with else ifs as long as you want. My variable equals 1.0, and each time you do an else if, you need new brackets. Print f inside the else if. And if you don't have to put an else at the end. If you don't want one of these to run guaranteed, then you can just leave it like this. and they will only run if the thing inside the if is true. But if you know that you want to check all these three things, and then if none of them are true, you know that this last thing should happen, that's why you would put an else here. Because the else will always happen if the first three ifs don't. Inside the else. This one's not really inside the first else if, inside the second else if. So let's change my variable to 5 and see how this works. So if I change this up here to 5.0 and I go back down, this first one's going to be false, this one's going to be true, and then it's going to stop. When you have ifs connected with else ifs, the moment it finds a true one, it does that code, and then it doesn't check the rest. That's on purpose. If you want it to continuously check a bunch of stuff, then you would not connect them all with else's. So let me run this to show. Oh, I've got some problems. Oh, it's got to be called printf. Do I have any more problems? Yep, there's another print. Oh, there it is, printf. In other languages, it's just called print, so I keep typing print. All right, so it just prints inside the else. Oh wait, I meant to make this one true, but I actually I checked my variable. I did not check my variable 2. So that's the one problem with naming things so similarly to each other. I meant to check my variable 2 with each of these. So let's try again. Make little Timmy dot slash. Now it says inside the first else if. But it doesn't do the other ones. It doesn't do this one either, because that's how connecting else ifs work.